Okay, so on to my first proof example here. So in this picture, we know that circle O lies in plane N. So again, we have the circle in the plane, and that segment RO is perpendicular to plane N. So again, if a segment or a line is perpendicular to a plane, then it's perpendicular to every line in the plane that passes through the foot. So I want to prove that segment RS is congruent to segment RT. So hopefully you're looking at the picture thinking, okay, so I see two triangles, and if I can prove those two triangles congruent, then I could get segment RS congruent to segment RT by CPCTC. Okay, so that is where we're headed. So I'm going to scroll down here. Okay, so I don't have to keep scrolling up and down, and I can just kind of do everything in the same screen here. Over on the right here, I'm just going to redraw the picture so we don't have to keep scrolling around here for my benefit. Okay, so again, this is R, O, T, S, and this is plane N. Okay, so again, we know that we have circle O in plane N, and that segment RO is perpendicular to plane N. So again, what we just went over, if a line is perpendicular to a plane, then it's perpendicular to every line in the plane that passes through the foot. So RO intersects the plane at point O. So we can state then that RO is perpendicular to OS, and we can also state that RO is perpendicular to OT. Okay, and my reason is just what I was saying a little bit ago. So if a line is perpendicular to a plane, then it is perpendicular to every line in the plane that passes through the foot. Okay, that's just what it means for a line to be perpendicular to a plane. Now, again, you should know that when you have perpendicular lines, you have right angles. So in this particular picture, my right angles are going to be angle ROS and angle ROT. So I'm going to state that next. So angle ROS and angle ROT are right angles. And my reason, if two segments are perpendicular, then they form right angles. And what would we do next? We should be on this kind of normal. We do this, this, this. Next, we're going to state that angle ROS is congruent to angle ROT. And my reason, if two angles are right angles, then they are congruent. Okay, so right now we have one pair of congruent parts. Okay, so we've got to get some other pairs to make this work here. So we always need 3 pairs of congruent parts to prove triangles congruent. Well, notice it said in the given that we had a circle O. We know that in a circle all radii are congruent. So segment OS is going to be congruent to segment OT. And my reason, all radii of a circle are congruent. So that gives me another pair of congruent parts. Well, notice also these two triangles butt up against each other. So we could say that segment RO is congruent to segment RO by the reflexive property. So that gives me 3 pairs of congruent parts. So we can state triangle ROS is congruent to triangle ROT by side angle sides. And again, if the triangles are congruent, the rest of the corresponding parts are congruent. So segment RS is congruent to segment RT by CPCTC. Okay, so again, just like the ones we saw in the previous lesson, we're still proving a lot with triangles congruent. Now we just have what it means for a line to be perpendicular to a plane to help us out with that scenario. Okay, if we look at the last proof then. Okay, so this time we are given that segment AB is perpendicular to plane M and that we have equilateral triangle DBC lies in plane M. And we are trying to prove that triangle ACD is isosceles. So to prove a triangle is isosceles, you have to prove at least two sides are congruent. Okay, so hopefully you're looking at that picture and thinking, well, if I could prove two triangles congruent, then I could get some sides congruent by CPCTC, which would then allow me to prove that the triangle is isosceles. Okay, so that's where I'm going to be headed with this one. So I'm going to scroll down here so we can see all the spaces and I don't have to keep scrolling up and down. Okay, so we can see on the right here, I've got the picture drawn, so I don't have to keep scrolling up and down the screen. So the first given said we have line AB perpendicular to plane M. So again, if a line is perpendicular to a plane, then it's perpendicular to every line in the plane that passed through the foot. So in this particular picture, we can state that line, or I guess segment I should say, AB is perpendicular to segment BD, because again, goes through at B. And we can also state that segment AB is perpendicular to segment BC. And this is the same reason that we talked about earlier. So if a line is perpendicular to a plane, then it is perpendicular to every line in the plane that passed through the foot. Okay, and so that's our main idea again for today, what it means for a line to be perpendicular to a plane. And again, if we have perpendicular lines, then we have right angles. So we can state next that angle ABC and angle ABD are right angles. Okay, so we have two right angles there. And my reason for right angles, if two segments are perpendicular, then they form right angles. Okay, and then continuing on like we usually do, if we have two right angles, we know they're congruent. So angle ABC is congruent to angle ABD. Okay, so again, angle ABC would be congruent to angle ABD because if two angles are right angles, then they are congruent. So if I'm trying to prove the triangle's congruent, right now I've got one pair of congruent parts. But the other given said the triangle DBC was equilateral. So remember, equilateral triangle means that all the sides are congruent. So segment DB would be congruent to segment BC, which would be congruent to segment CD. Now technically I don't need all three, but I'm going to go ahead and list them anyway. So again, my reason would be if a triangle is equilateral, then all sides are congruent. Okay, so right now then that gives me two pairs of congruent parts. Notice triangle ABC and triangle ABD, bless you, butt up against each other. So we can state that AB is congruent to AB by reflexive. And that's your three pairs of congruent parts. So we can now state that triangle ABC is congruent to triangle ABD by side angle side. And again, if the triangles are congruent, the rest of the congruent parts are congruent. So if I want to prove that triangle ACD is isosceles, the part that would help me would be stating that segment AC is congruent to segment AD by CPCTC. And again, if that tells me that triangle ACD has two congruent sides, then the triangle is isosceles. And my reason would be something like, if a triangle has at least two congruent sides, then it is isosceles. Okay, so for today, you have an assignment in the textbook, page 278. You're going to do numbers 2 through 14 even. Have a great day.